Hi, today we are going to talk about and respiratory system. Let's go straight into it. Okay, when you talk about air, actually it means gas lah. Okay, it generally refers to a lot of different kind of gas. Okay, because under the word air, actually there are many different kinds of gas lah. Okay, I'll just list a few common ones here. Okay, nitrogen take up the most percentage of air. So like let's say for example right now around you there are a lot of different gas around you, okay, and most of them is actually nitrogen, okay, which is a good thing lah because uh nitrogen don't support burning lah, okay, it's not that reactive, so it's a safe gas. When I talk about reactive, that means it reacts to chemicals, it reacts to things like for example burning, okay, because in case you don't know, fire needs oxygen to burn lah. So if you have a lot of oxygen around you, it's actually dangerous because if there's fire, it will spread very fast. Okay, the second most common air is oxygen. But I mean, if you look at it, when you compare it to nitrogen, it is not as much, but it's still quite a lot, okay, compared to the rest of the air. A reason because you should know oxygen is very important. Okay, all living things need oxygen to stay alive. Then carbon dioxide. Carbon dioxide is actually not that much, okay, around us, but it's also quite an important gas lah, which we'll discuss later. Water vapor is also quite common, and then there are other gases. Of course, you realize that the percentage don't add up to 100% because this is an estimated number. It's not 100% accurate, but in general, nitrogen is always the most. It always take up the most, and it's definitely more than half. Okay, usually near to 3/4. Okay, and the second most common is oxygen. Now you do not have to memorize any of the gas here, as in the percentage wise. You do not have to memorize the percentage. You will not be tested. However, you must know nitrogen is the most, oxygen is the second most. Okay, you must have a rough idea of how much they take up when you are given a pie chart, because sometimes exam do come out and ask you which is the most common air, or sometimes the exam they will show you a pie chart and ask you to label which one is nitrogen, which one is oxygen. Okay, so you must know the size roughly, but you don't have to know the percentage. The percentage will not be tested. Okay, so there are other gases. Sometimes they are called inert gas, sometimes they are called rare gases. Basically refers to gas that is not so commonly found. Okay, these are a few examples. Okay, I'll talk about argon and helium lah. Actually they are not tested, but just your general knowledge lah. Argon is a kind of non-reactive gas, so it's usually found in the light bulb. Okay, you should know that any place that's empty will be filled with air. So the air that we intentionally fill with in light bulb is argon because it will prevent the filament from oxidizing lah. Okay, helium, that means the filament will spoil. If there's oxygen inside, it will spoil easily. Helium is the air that you use to pump your balloon, which allows the balloon to float lah. Okay. Then the other common word is wind. Wind is basically any kind of air that is moving. Okay, so wind is actually not a type of gas, but it's just referring to any kind of gas that is moving. Okay, now let's go into the most important air around us, which is the oxygen. Okay, now we should know that all living things need oxygen to stay alive lah, because we need to breathe, we need to respirate. Okay, it is mainly produced by plants and phytoplankton. Actually, in case you don't know, most of the air is actually not produced by plants but by like phytoplankton. I think it's about 70-80% of them, of the oxygen, is produced by them. So they are very important. They are actually algae that's found in the water. But you will not be tested this word in primary school, so don't know that. Okay. So I think by now you should know when plants make food, right? They will take in carbon dioxide. They also take in water from the roots that goes to the leaf. So now the leaf taking carbon dioxide through the stomata, and then water goes to the leaf via the roots, and then the water carrying tube. Then also they'll take in the light, okay, using the chlorophyll to trap the light. So when these three ingredients, okay, or substances lah, your light, your carbon dioxide, and your water comes together, it produces food for the plant. At the same time, it also produces oxygen. Also, that's how oxygen is produced when the plants photosynthesis. Okay, so that's why plants are very important, because they produce oxygen. We cannot produce, animals cannot produce oxygen. So they provide oxygen for us, that's why we are able to stay alive. Okay, now, so what is oxygen used for? Okay, it's used for breathing and respiration. Actually, there's a difference between breathing and respiration. That's why I separate it. Later, we'll discuss in details why they are different. They're also used for burning. In case you don't know, fire need oxygen to burn. So if you deprive of fire oxygen, right, okay, something like this will happen. Okay. So what you are seeing here is that the fire goes off, right? The reason why the fire goes off is because when the flame on the candle that's burning inside the glass, it uses up the oxygen and produce carbon dioxide. So after some time, when you finish using up all the oxygen, there are no more oxygen to burn, right? You stop burning. Okay, so that's why oxygen is also dangerous, because forest fire, I don't know if you heard it, in Singapore it seldom happens, but in many other countries, like for example in Brazil you have the Amazon forest, in Australia also you have very big forests, where all these forests they have a lot of oxygen because there are a lot of plants. So when there's a lot of oxygen in the forest, if one or a few tree catches fire, the fire will spread very fast. Okay, because there are a lot of oxygen for the fire to burn. So that's why forest fire is very dangerous. They spread very fast because forest has a lot of oxygen for them to burn. Okay, then the second very important gas is carbon dioxide. As you know, no living things on earth can actually create food. Okay, and we cannot create food, so only plants can do that, and plants need carbon dioxide to create food. So if plants don't have carbon dioxide, they cannot photosynthesis. If the plants cannot photosynthesis, we won't have oxygen, we won't have a source of food. Okay, because yes, we may be eating other animals, but these animals will still be eating plants eventually. So the plants is a source of oxygen as well as a source of uh, food for us. Okay, regardless directly or indirectly. So that's why carbon dioxide is very important for plants. So since carbon dioxide is very important for plants to survive, it is also very important for us. Okay, so this is how air cycle will usually go. So animals, okay, not just the giraffe most animals, okay, as well as us, we will produce carbon dioxide when we breathe. Okay, even for plants they also breathe, right? So they also produce carbon dioxide. That's why you see this arrow here. So all these carbon dioxide, regardless it's from the plant itself or from other animals, okay, or from other ways like for example burning or decomposition, eventually it goes to the plants, or like I say, the phytoplankton. Okay, then they'll use it and then they'll turn it on oxygen. Then the oxygen will be used by us or the plants, and then you turn into carbon dioxide again. So that's how it keeps going on and on. This allows the earth to have a sufficient amount of oxygen. Otherwise the oxygen will be used up and everyone will die. Okay, now, so as I was telling you, it's important because plants use it for photosynthesis, which provide us with oxygen and food. Okay, so when is it produced? Just like I already told you, it's produced when you burn. Fire burns in the oxygen to burn. When we breathe as well as when we respirate. Okay, later I'll tell you what's the difference between respiration and breathing, as well as decomposition. Okay, when you are P3, probably you have learned about fungi and bacteria. They are decomposer that performs decomposition. That means they break down dead and waste into simpler substances. This when they are doing that, when they do decomposition, other than producing simpler substances, they also produce carbon dioxide. Not only they do that, actually they also produce water vapor. But the main purpose is to produce these simpler substances. But at the same time, they also produce byproducts like water vapor and carbon dioxide. Okay, the other thing you need to take note about plants is that they produce more oxygen than the oxygen they use. Okay, let's think about it in terms of units. So let's say, for example, the plant uses 10 units of oxygen to respirate, to breathe, but it also only produce 10 units of oxygen during photosynthesis. At the end of the day, there will be 0 units of oxygen balance, right? There won't be any oxygen for other living things. So that doesn't make sense. So if they were to use 10 units, okay, to respirate, they will definitely produce more than 10 units so that there will be sufficient oxygen for other living things. So always remember, plants produce more oxygen than what they use. Okay, this is important. Okay, water vapor. Water vapor is basically, if you have studied the water topic, water vapor is basically uh, water in gaseous state. Okay, it is very important for water cycle. It's also very important for humidity. Okay, humidity is basically the amount of water vapor in the air. Okay, it is produced during evaporation. So let's say you have a puddle of water, they will gain heat and then they will turn into water vapor lah. Okay, when we breathe out also we will produce water vapor. A simple way is you can sometimes I think you all do this, you can breathe out or blow your breath onto a glass, for example. You realize that there will be a layer of mist form. That's because the water vapor that comes out from our body is warm. It comes into contact with the whatever surface that you blow onto. Okay, so you lose heat, right? So when you lose heat, the water vapor that comes out from your body, they will condense. That's why they will turn into water droplets and form on the surface. Okay, they are also produced from stomata. These are stomata. Okay, stomata is basically holes that's found on the leaf. In case you forgot, okay, you should have studied this in the plant transport system lah. So for us, we use the nose to breathe. For plants, they use stomata to breathe. But this nose also releases water vapor. Okay, water vapor is also produced during decomposition, like I tell you. So during decomposition, the fungi and bacteria turn dead and waste into simpler substances. They also produce byproducts like water vapor and carbon dioxide. Okay, dissolved air. It's actually not commonly discussed, but you should still know this, okay, because it will help you in answering your science question. Dissolved air, like the word dissolve suggests, that means it's mixed with something and it's dissolved. It's just that, for example, you pour a packet of sugar into water, it will disappear, right? That's because the sugar has dissolved into the water. So when the air has mixed with the water, it's called dissolved air. Okay, so it can be your dissolved oxygen, it can be your dissolved carbon dioxide lah. Okay, how do you create it? Actually, there are a few ways. Okay, let's talk about the more common ways lah. Man-made method is your air pump lah. Okay, if you have a aquarium at home, okay, a fish tank at home, you should have probably have an air pump lah to keep your fish alive. Because fish needs to breathe air, right? But fish, they have gills, so they can only breathe the air in the water, which is known as dissolved oxygen. So in order for them to breathe the dissolved oxygen, something must be producing it lah. Okay, that even if the water has dissolved oxygen, eventually you still use that one. So an air pump, what it does is you pump air from the outside into the tank, so the air from the outside will mix with the water to create dissolved air. Okay, or if you don't have a choice, you can actually stir the water in the fish tank lah. Okay, by stirring it, you are actually mixing the air around it with water as well. Okay, naturally also you can use water plants. Okay, some people, their fish tank, they also put in water plants. These water plants will photosynthesis, so they also produce oxygen which mix with the water to produce dissolved air lah. Okay, wave is actually because of the gravitational pull from the moon. So the water in the ocean will move. Okay, that's one of the reason. So when they move, what it does is it will create dissolved air. Okay, mixing the air in the surrounding with the water. Okay, so what is breathing? Okay, before I talk about respiration, let's talk about breathing first. Breathing is basically when you take air in and give out air. You can call it inhale and exhale. You must know what's the meaning of inhale and exhale. Okay, because sometimes during exam they use this term. Okay, now the confusion is this. We have always been brought up to think that we breathe in oxygen. Now that's not true. We need oxygen, yes. We need oxygen. We need to take in oxygen. Okay, if you don't take in oxygen, our body won't have enough oxygen, and then we can actually die from it. That is true. We need oxygen, and we need to breathe it in. However, our nose is not very intelligent. Our nose cannot say, "Oh, all the gas around us, I'm only going to take in the oxygen." No. So unfortunately, our our nose will take in any kind of gas around us. That's why sometimes people can die from things like carbon monoxide poisoning. Okay, so our nose basically taking all kinds of air. It doesn't just take in oxygen. So in fact, because of the fact that in our surrounding, most of the air is nitrogen, right? So actually most of the air that we breathe in is nitrogen, not oxygen. Although oxygen is still quite a huge percentage. So please know that when we take in air, we take in any kind of gas that's around us. Okay. So we don't just breathe in oxygen, also nitrogen, also helium, argon, carbon dioxide, water. We also breathe all this in. Okay, we usually breathe in through our nose, but we can also breathe in through our mouth. What's the difference? Actually, not much difference, just that our nose have nose hair to trap dust. So any unhealthy particles will be blocked. Okay, provided the particles is bigger than the nose hair. Okay, so when we breathe in and we breathe out, what's the difference? Okay, inhale that means breathe in, exhale that means breathe out. You must know this word. It's very easy to remember because of the word in and ex. Take in and exit. Okay. Actually, there's a change in percentage, but I will not talk about the percentage because it's not tested and it's impossible for you to memorize so many things. So when we breathe in, right, okay, there's oxygen, like I say. Okay, I wouldn't say more oxygen. I'll just basically, what I'm trying to say here is the oxygen will decrease. That's why I say when you breathe out, you have lesser oxygen. Reason because our body will use up the oxygen, right? So when we breathe out, there will be less oxygen. And also, this is a confusing part. A lot of students will think that when you take in oxygen, you use up all the oxygen that you take in. That's not true. Okay, even for huge mammals like whales or elephant, they don't use up all the oxygen that they take in. Okay, for us, when we take in oxygen, we only use a bit of the oxygen. Actually, we don't. We use very little of the oxygen we breathe in. Okay, a simple experiment. Actually, I shouldn't say this lah, but sometimes you all like to cover your mouth with a plastic bag, right? And then you realize that you can breathe a few times. Or that's the reason is because when we breathe in, right, we don't take in all the oxygen. So when we breathe out, there is still oxygen content. That's why you can still breathe in again. But I mean, I'm just telling you, don't do this experiment on your own. It's actually not safe. So anyway, so take note. When we breathe out, we also breathe out oxygen. Reason because we don't use all the oxygen that we breathe in. Okay. And when we breathe out, there will be more carbon dioxide because, like our body will use up the oxygen that we breathe in and turn them into carbon dioxide. That's why when you breathe out, there will be more carbon dioxide. Okay, there will be an increase in carbon dioxide. Water vapor also, there will be an increase in water vapor. There's few reasons why, and sometimes actually they do test you. So please know this. The first is because the nose actually has this our nose actually can moisten the air that we breathe in. Moisten, that means add water to it. So that's why when we breathe out, the air that we breathe out has higher water content. Second reason is because actually, in case you don't know, about 70% of our body is actually made of liquid. So because of the fact that our body has a lot of liquid, that's why the air that goes into our body will also gain liquid. Okay. Then the other reason is because when we breathe in, okay, our body do respiration, which I'll talk about later. And during respiration, they'll produce water. So when we breathe out, there's also more water vapor. So basically, when you breathe out, there's an increase in the water vapor. Okay, then let's talk about the temperature of the heat of the air that we breathe in. Okay, you can do a simple experiment now. Okay, you try to breathe out air onto your hand now. You realize that it feels warm. Okay, then you think that when I breathe in, the air that I breathe in don't feel warm. Why is it that when I breathe out it feels warm? Reason is very simple. Let's talk about just Singapore. The room temperature is probably less than 30 degrees Celsius or around 30 degrees Celsius. And you should know that your body temperature is about 36, 37. So this means that the air around us is also about or less than 30 degrees Celsius. So when it enters your body, right, your body is warmer than the air that you breathe in. So what happens? Heat travel from a place of higher temperature to lower temperature, right? So the air that goes into our body gains heat from our body. So when it gains heat from our body, the air become warmer. So that's why when we breathe out, the air become warmer than the air that we breathe in. Okay, simple as that. Basically, in summary, the air that we breathe in gain heat from our body So as I was telling you, okay, please know this Okay, our lungs do not take in all the oxygen that we breathe in. They only take in a bit of oxygen that we breathe in. Okay, and when we breathe out, there'll be more water vapor. Okay, because our body is mostly liquid, and the nose actually moisten the air, or as well as because of respiration. Now let's talk about respiration. Later I have a comparison chart, but for now just look at what is respiration. Okay, now what's the difference between, one of the main difference between breathing and respiration is that for breathing, right, it's just your nose and your mouth, right, that take in air, give out air. It's simple as that. But for respiration, right, it occurs at every single part of your body, because you should have learned unit of life, right? Unit of life, it's telling you that every single cell of every single part of body is made of cells, and every single cell is a living thing on our body. So because they are all living things, they need air, food, water. So actually, to put it simply, one of the main reasons we drink, we eat, and we breathe is for ourselves, because the cells in your body needs air, food, and water. Okay, so during respiration, all the cells in our body will need to do this process called respiration to produce energy, okay, to keep them alive. Okay, so all the cells in your body, they use the oxygen and the digested food that we eat, that we digest, as well as the oxygen that we breathe in to generate energy lah. Yeah, do a simple equation for you. So somehow this oxygen will travel to every single cell of the body. Actually, it's not somehow. Actually, it's through your circulatory system. Your blood will bring it to all parts of the body, along with the digested food. Okay, so this oxygen and digested food, let's say it goes to your muscle cells. Okay, the muscle cells will use them and generate and turn into energy, which is what you need. Or that's why we need to eat and breathe, because we need energy. Or not just energy to move, it can be energy just to keep you warm. Okay, but at the same time, you have a byproduct. This is a byproduct. Okay, you don't really have to know this word byproduct. Byproduct, that means what is produced by what you don't need. Your main purpose is to produce oxygen. Okay, but at the same time, they also produce carbon dioxide and water. Okay, so as of now, I hope you should have a better understanding of what is respiration and breathing. Basically, part of respiration is a very complicated process, as you can see, and part of it involves your breathing, because respiration requires you to take in oxygen and to give out carbon dioxide. Okay, now let's talk about our respiratory system. Your respiratory system is basically organs in your body that work together to help you respirate and helps you breathe. Okay, before I talk about how the air moves, okay, I just briefly identify with you all of them lah. This is obviously your nose. Okay, the below one is your mouth lah, but I will not be talking about it, because in your primary school textbook or syllabus, mouth is not part of the respiratory system. Mouth belongs to the digestive system. Okay, now then this is your windpipe, or if you know the scientific term, is called esophagus, but it's not tested. Okay, it's very important, easy to remember, windpipe. Then this part here, all this is your air tubes. Okay, then all these small branches out is actually your air sacs. They look like balloon. Okay, then the below part is our diaphragm. Okay, diaphragm you don't have to know how to spell. Okay, it will not be tested. Okay, but you must still know what a diaphragm do. Diaphragm is basically a muscle that's found below your lungs. Okay, it basically helps you to breathe. So to summarize, diaphragm is a muscle that helps you breathe. So anyway, let's look at how the air moves. Okay, so like I said before, the nose and mouth is the one that take in the air. So after the air goes in, it goes to your windpipe. Okay, it's very straightforward. Just refer to the picture can already. Then you go into your air tubes. Okay, you branch out to two sides because we have two lungs. Then the air tube will transfer the air to all your air sacs. Okay, there are a lot of them. And then the air sacs, what they do is the air sacs will pass it to your blood vessels. So as of now, you should realize all these air sacs is actually found inside our lungs. Okay. Now the other thing you need to know is this. So this is basically the organs in your respiratory system, as well as your lungs. Okay. Then the blood vessels is our circulatory system. So I'll do the circulatory system on another video. Okay. So I do a quick run through again. Okay, the air go through here, nose, goes to air tube, goes to the windpipe, then goes to air tube, then goes to air sacs. Okay, then you pass to the lungs, then the lungs will bring it to all parts of the body. Okay, so a lot of students will also think, if I have lungs, why do I need an air sac? Okay, there are a few reasons. Okay, there's actually a difference between lungs and air sacs. So lungs, inside our lungs, like I tell you, it contains all these very, very small balloon-like structure, which is your air sacs. Okay, so this is how our air sacs look like. Here diagram. Okay, so you can see that it's spread by all these lines, right? Well, all these lines are blood vessels. So the blood vessels will bring the blood to all these air sacs to collect the oxygen, and also at the same time to give back the carbon dioxide, so we can breathe out the carbon dioxide. Okay, because like I tell you, during respiration we produce carbon dioxide, so the carbon dioxide is a waste, it's something that you don't need, so it needs to be passed out from body. That's why the blood vessels needs to go and bring the carbon dioxide out from all parts of the body, put it to your air sacs, then the air sacs will bring it by your windpipe, and then you breathe it out. Okay, so air sacs is inside the lungs. Okay, it branches out from the air tubes. Okay, now so I keep saying that it is balloon-like. So why lah? Okay, it's because a round shape will have more surface area. Okay, as compared to having one huge piece of lungs. Okay, we now has many small balloons inside the lung. So this increase the surface area. When the surface area is increased, the gaseous exchange between the air sacs and the blood will be faster because more surface area. Okay, so it exchange gases with the blood. Okay, so this is another zoom in. Okay, if you zoom in, I mean, if you just look at one air sac, what it do is the blood vessels will pass through. Okay, then when it's passing through, you put the carbon dioxide that they don't want, then this air sacs will bring it out from our body. Okay, then we breathe out. Then the oxygen that comes in, it goes into the blood again. Then the blood will bring the oxygen to all parts of the body. So it goes to all parts of the body already. All the body will start already. No, this one you study in detail in circulatory system lah. You go back to your air sacs again. That's why. So this is a simple comparison of breathing and respiration. Like I tell you, breathing is part of respiration. Okay, and breathing takes place in the nose and mouth only. But respiration takes place in every single cell of our body. Then for breathing, right, you just take in air, give out air. But for respiration, it's a complicated process where they turn digested food and oxygen into energy, as well as your carbon dioxide and your water. Okay. Then let's look at how other living things breathe. You should also know this. Okay. Anyway, I mean it can also be tested for PSLE. Anyway, it's a P3 topics. Okay, some of them. So plants they breathe through stomata. Okay, is this holes that is found on the leaf. So, or you can say actually plants breathe through leaf because the leaf is where the stomata is found. Then fish breathe through gills Okay, gills is designed to breathe dissolved air. So that's why fish cannot come on land to breathe. Because they cannot breathe in normal air, they must breathe dissolved air, dissolved oxygen. Okay, which is basically air in the water. And likewise, human beings, okay, we cannot breathe in the water because we don't have gills. Our lungs is designed to breathe air on land, oxygen on land. Okay. So birds and mammals is the same. Sorry, I jump a bit. So birds and mammals, they breathe with lungs. Okay, let's go back to amphibians. Amphibians also breathe with lungs. But you should know that amphibians live on land and on water, right? The reason why it can live inside the water is because they have a very special kind of skin called moist skin, which allows them to breathe dissolved air. That's why they can breathe inside the water, because they use their skin to breathe in the water. When on land, they don't breathe with their skin, they breathe with their lungs. However, if when they come on, amphibians come on land, their skin is still wet, right? Then they can also breathe with the skin. So actually, when on land, amphibian can breathe with both lungs and skin one. Okay. Then for insects, they breathe with breathing tube Okay, you should be quite familiar if you remember the life cycle of a mosquito. They are young, the wriggler, breathe with this breathing tube when in the water. Okay. So why is it that wriggler or the larva of mosquito can live in water? It's not because they have gills. No, they are insects, they don't have gills. The reason is because they have this breathing tube. It's like they use a straw to poke it out of the water surface to breathe. Before we end, maybe I'll just do a summary again of what we have learned, okay, about air and respiratory system. So when we breathe, this is what happens. The air goes in through the nose or the mouth. Okay, usually we refer it to the nose just for primary school science. Then you go into your windpipe, which will branch out to lungs via the air sacs, and then in the lungs. Sorry, let's restart again. Okay, before I end, maybe I'll just do a quick run through of what we have learned. So the air will enter either through your nose or mouth, but for primary school, you just take it as they enter through your nose. Okay, then you go to the lungs, which will branch out to two air tubes, which will direct it to the lungs, and then inside the lungs is where your air sacs receive all this oxygen. Then these air sacs, right, you put all this oxygen into your blood vessels while also taking out carbon dioxide. So they will take out carbon dioxide from the blood, and then they also put in new oxygen. Okay, then the blood will carry it to all parts of the body lah. Okay, then after that, what about the carbon dioxide that they take from the blood? Okay, the carbon dioxide they take from the blood will return back, okay, to the air tubes. Then the air tubes will bring up the windpipe, and that's how we breathe out. Okay, so that's why when we breathe out, there's more carbon dioxide. And as I was telling you, when the air enters our body, is being moistened. That's why there's an increase in water vapor. Also, because the air that enters our body gain heat from our body, that's why the air comes out has a higher temperature. Okay, then because we used up some of the oxygen already, some of the oxygen is taken out and put into the blood already. That's why when we breathe out, there's also less oxygen. Okay, so that's all for today. Thank you for watching the video. If you can, please share this video with your friends.